Today's lesson is on finding the area and perimeter of compound shapes and the shaded region of shapes. So we're going to start with some review of how to find the area of special quadrilaterals, then more review of how to find the area of triangles, then we're going to move on to the area of compound shapes, the area of shaded regions, and finding the missing pieces of compound shapes. So let's start with the area of quadrilaterals. Here is a graph of showing all the different types of special quadrilaterals, and we'll start with a rectangle. And we know that the area of a rectangle is base times height. And we've learned that that's actually true for all parallelograms. Base times height is the area for all parallelograms. So let's find an example of that. The area is base times height. Then I can plug in my base of 6 and my height of 4, multiply them out. I know the area of that rectangle there is 24. The area of the parallelogram is also base times height. My base is 6. My height, which is perpendicular to the base, is 3. Plug that in and I end up with 18. So the area is 18. The next group of quadrilaterals we want to look at are trapezoids. And for trapezoids, it is the average of the bases times the height. I have two different bases in every trapezoid, the parallel lines, and I take the average of those times the height. So here's an example. Here's a parallelogram, the average of the bases times the height. There are my bases. The average of my bases of 5 and 7, the average is 6. So I can plug that into my equation. My height, which is perpendicular to my bases, is 2. So I can plug that in. And therefore, the area of this trapezoid is 12. The final type of special quadrilateral we have are kites. And for kites, the area is 1/2 the diameter 1 times diameter 2. Since a kite has opposite sides that are equal, has congruence has adjacent sides that are equal, then this formula also works for other shapes that have adjacent sides that are equal. For example, a rhombus and a square. Now let's move on to the area of a triangle. If I take a triangle and I create another triangle exactly like it, and then I rotate that triangle 180 degrees around, I have created a parallelogram. And we just learned that the formula for the area of a parallelogram is base times height. But this parallelogram is made up of triangles. And how many triangles? 2 triangles. So if the area of a parallelogram is base times height, and there are 2 different triangles in that parallelogram, then each of those triangles is 1/2 the area of a parallelogram, or 1/2 base times height. So let's go through some examples of the area of a triangle. It's the same formula no matter what kind of triangle we have. If we have a right triangle, then I just substitute in for base times height. In this case, 7 is my base, 4 is my height. Multiply those out, I get 1/2 of 28, or 14 is my answer. For an acute triangle, again, my formula is 1/2 base times height. My base is 4, substitute that in. My height, which is perpendicular to the base, is 2. Plug that in, and I have 1/2 of 8, or 4. The area of this triangle is 4. Finally, for an obtuse triangle, once again, it's the same formula, 1/2 base times height. 1/2 base times height. My base is 7 in this case, so I can substitute that in. My height, which is perpendicular to my base, is 10, so I can substitute 10 in for height. Multiply that out, I get 1/2 of 70, or the area is 35. So the area of this triangle is 35. Now that we've done our review, we can actually move on to the area of compound shapes. So if we want to try to find the area of this shape below here, what we have to do is we have to break it down into shapes that we know. and can find the area for. And so for this particular example, I have this shape can be broken down into a parallelogram and a triangle. Then we just have to find the area of each of them and add them together. So the area of the parallelogram first, then the area of the triangle. So for the area of a parallelogram, as we just learned, is base times height. Substitute that in, and I get the area of this red parallelogram is 80. For my triangle now, I have to find the base, and if the base on the left-hand side of the parallelogram is 8, then on the right-hand side that is 8, which is the base of my triangle. So now I can plug that in. The area of a triangle is 1/2 base times height. My base is 8, my height is 9. Multiply that out, and I get 1/2 of 72, which is 36. So now I know the area of my red parallelogram and my blue triangle. To find the area of the whole shape, I need to simply add them together. So 80 plus 36 added together is 116. So the area of this compound shape is 116. Now let's talk about the area of a shaded region. Sometimes you'll be asked to find area of a shaded region made up of two shapes, or it could be even more than two shapes. And so the thing to do is to find the area of each shape and then subtract as necessary. So here's an example. I'm asked to find the area in yellow. It's a parallelogram with a right triangle inside. So the first thing I need to do is find the area of my parallelogram, which we know is base times height. So I can substitute in 20 and 15 for my base and height, and I know the area of my parallelogram is 300. Next, I need to find the area of my triangle, which is 1/2 base times height. My base is the 20 minus the extra 6 that's there, and my height is 15. So that's the same thing as 1/2 of 14 times 15, which is 105. Now that I have the area of my parallelogram and the area of my triangle, to find the area in yellow, I subtract the two. So that would be 300 minus 105 would give me the area in yellow is 195. Now let's move on to a perimeter problem. To find the perimeter of this shape, I have to first find this side over here x, which I'll call x, this side over here y, and then I simply add up all my sides. So I need to simply determine what x and y is, substitute them into the equation over on the right, and add them up. So I notice that over on the left, this side is 14. And so if that blue is 14, and this is 14. And the top piece is 4, and the whole piece is 14. So if I want to find the bottom part, which I've put in green here, that would be 14 minus 4, or 10. So I know that that line in green is 10. And if that line in green is 10, then this line in green is 10, so x is 10. Similarly, on the bottom, I see that my base is 30. I'll put it in yellow. And so if that's 30, then this line also in yellow is 30. And if this piece of the yellow line over here is 7, and the whole line is 30, then this red piece right here would be the difference of the two, or 30 minus 7, which would be 23. And if this piece right here is 23, then up top it is also 23. So I can substitute in 23 for y. Now I simply have to add up all the different sides of my compound shape, and when I do, I get 88. So the perimeter of this compound shape is 88. Next, I have to find the area of that same compound shape, and we learned from our last problem that the x is 10 and the y is 23. Now to find the area of a compound shape, I have to break it down into shapes that I know and can find the area and can find the area for. So if I draw this line here, I'm going to create two rectangles, this one in blue and this one in red. And together, that compound shape is going to be equal to the blue piece plus the red piece. So first let's figure out the blue piece. So it's a rectangle, so the formula is base times height. Substituting in base times height, I have 14 times 23. Multiply that out and I get 322. Now we'll add the red piece, which again is base times height. Substitute in my values, 7 and 10. 7 times 10 is 70. So now I simply have to add the two up. 322 plus 70 equals 392. So the area of this compound shape is 392.